So in this video, we will talk about IPv4 design for a new service. In, let's say, 2 data center, and this is just an example. So assuming you have address space, which is private, /8, and you choose a 10.1 to deploy this or design this new service. For 2 data centers. So how can we do a design with a /16 for 2 sites? So let's start drawing that. So you can do /16, which is first octet, second octet. You can break the third octet into 2 subnets and make this, since it's 2 data centers, a 0 subnet into 17. We're taking a 16, taking the first bit of this third octet, therefore /17, and the second one is first subnet is 0, the second one is going to be 128.0/17. Just to review that, we have the octet that is IPv4 octet that is laid down, or is an 8-bit number that you can use to design your network IPv4 addressing scheme. So in our case, here's the 8-bit number. The first bit of any octet is 128, and that will give you 2 network subnets. This one will give you 4. This one will give you 8, 16, 32, 64, 128 subnets, and 256 addresses. So these are the networks. Now, based on this, you can determine how many nets you need and then further subnet that. So let's just say that our third octet is a /17. So this guy is a /17, 18, 19, 20, 21, 22, 23, 24. And if you keep going for the last octet, 25, 26, 27, 28, 29, 30, 31, and 32. That's your 32-bit numbers, okay? So we're taking and splitting a /16 into 2 subnets. The first one is a 0, and the second one is 128. 2 subnets, 0 and the 128. Now let's draw our network. So let's say we got 2 WAN routers. And they could be connected to each other through a cloud, or just for this example, they're connected through a point-to-point link, and these 2 WAN routers exist already, right? What we're trying to do is we're trying to put a new service for the data center. So that's typically the WAN routers would be connecting to, let's say, an L3 core switch, right? And then that core switch will be connected to another L3 device, mostly firewalls or maybe an L3 switch, depending whatever it is, right? Let's just give them 2 each. So these links are point-to-point links, meaning they require only 2 addresses, but we will go ahead and use a /29. So now this is our WAN router. This is our WAN router on the second site, DC1, DC2, L3 core switch, L3 core switch, and then L3 device, whether it's a switch or a firewall. Now we need to deploy this addressing scheme that we have carved out. Using this addressing scheme, we will start addressing our new service, assuming that this guy is already addressed and connected and routing is happening. We're just deploying this new service, probably a new link to an L3 core, and even that is, for example, most likely it will exist, but just for the sake of designing this V4 addressing scheme, we'll just address all the links here. So we'll use the /29 because it will give us for the transit links, and the transit links are these, and we'll use a /29. You can use a /30, which strictly gives you 2 addresses, right? So the network in a /30 is 0, 4, 8, 12, 0 would go from 1 to 2, 3 is a broadcast. This one will go from 5 to 6, 7 is a broadcast. This one will go from 9 to 10, 11 is a broadcast. So you strictly get 2, and you can use /30, but for simplicity's sake, or for an example's sake, when you get into the data center, you may have a situation where you have more than 2 IP addresses that are required. For transit links like these that are pure point-to-point, you can use /30s, but once you get deep into the data center, using a /29 is probably a good idea, unless you're sure that you're going to be using a point-to-point link. Okay. All right, let's take this first subnet from 10.0 and 10.1.0 and 10.1.128 for transit links. So we take the 0 subnet, first subnet 0, and the second subnet 128 for transit, and then we'll design everything else after that. So our first subnet transit link addressing would be 10.1.0/29. The 0 subnet, so /29 is 8. So this is going to give you 0 for subnet is 0. 8, 16, 24, 32, and so on. So erase this for a second. And so the first one will give you 1 through 6 addresses. The second one will give you 9 through 14. 7 is broadcast, 9 is broadcast, 15 is broadcast. This one will give you 17 through 22, because 23 is a broadcast, and so on and so forth, right? So let's take the first one, 0, and address this link, .1, we're using /29 right here, and .2. And you can use anything between 1 and 6. This link would be 10.1.0, and I apologize, this is the subnet, and we're using /29 for this guy. So this is going to be 10.1.0 now. It's going to switch to the next one, which is 8/29.9.10. This one is going to be 10.1.0 / next one is 16. We got 0, got 8, 0 was here, 8 is here, and then we got 16 for this guy, /29. This is going to be 17.18. You can use 19, 20, 21, whatever, anything between this address ranges. Okay, so here's your /29s that you got. Now on the WAN routers, obviously, you're going to advertise 10.1.0/17 to this WAN router, and you are going to advertise 10.1.128.0/17 this way to this WAN router, so the routing would work. So now they both know where these subnets exist, the 0 and 128. So we got these, and now let's go in, and these were the transits. Now let's look at the stubs. Stubs are your VLANs. So your VLANs will go 10.1. You're using the 0 subnet for the transit, so you're not going to use the 0. Now you're going 10.1.1.0/24, and that these VLANs can span between these these 2 or more L3 switches or L2 switches that are hanging below them, right? All the way to 10.1.127.0/24. So you got all the way from 1 to 127 on this /16. 0 was used for transit, and 1 onwards for stub networks. Let's do the same here. You take 10.1.128.0/29, and /29 is again 0.816. So you're going to take .1, .2, 10.1.128.8/29, .9.10, 10.1.128.16/29, .17, .18. And then the stubs. Or the VLANs would be 10.1.129 because you're using 128 for your transits. .0/24 all the way to 10.1.255.0/24. So here's a simple example of taking a /16, splitting that up into two /17s, routing between them, and taking their transit links, addressing their transit links and stub networks or VLANs. Now, obviously, when you do something like this, you will also have to determine, in this case, there are only 2 sites. If you have more than 2 sites, then how would you split a /16? If you want 4 sites, then you will probably take a /18. If you have 3 sites, then obviously you're again going to take a /18 and split them into 4 subnets and assign the 3 sites, and the 4th one would probably be used for addressing the transits. It all depends, but this is just an example. The more number of sites grows, the more complex this becomes. But this is a typical 2 data center design where you can go and implement a new service based on the /16 that is available for you. I hope this helps.